Welcome to the Cosmos Chat podcast. I'm Viraj Bhardwaj, the host of this show, and today with me is Savri Gandhi. And first of all, I want her to introduce herself.
Okay, so hi everybody. My name is Savri Gandhi. I just got done with my bachelor's in mechanical engineering a week ago. Other than that, for my final semester, I've worked as a thruster research associate at Reusable Space Technology. So we were developing green propulsion systems for satellites. Um, Besides technical stuff, I have a huge enthusiasm for science communication, and I have a YouTube channel called Savri Space where I share concepts related to science and space technology with the general public. So that's just a very brief introduction of me.
So today we are going to talk about reusable space technology. It's a technology which is really useful for us, and it's currently in the market. Like SpaceX Falcon 9 is a really famous one in this whole technology, and it represents it very clearly. It is launched many times, and it is getting success. So this technology is really helpful for us, and if just we revolutionize, if we want to revolutionize the human society, then technologies like this that is using less resources and is more productive, it's going to be great. So Sabri, first of all, I want to know how you got your interest in space and astronomy.
Sure. So I think the earliest point I can remember in my life when I was about 4 or 5 years old was being very interested in the concept of planets because it was a very alien thought that this is one planet that we're living on and there are so many others like it. And I think you're in school you're made to memorize like the order of planets like Mercury, Venus, Earth, Mars, and so on. And that kind of instigated that curiosity in me regarding planets and the solar system in general. And again, that is how I found out that there's a job called as the astronaut. And I think when you're that young, almost every kid thinks of astronaut as a potential career choice. So whenever, like when I was growing up, I would just walk around telling people, yeah, I'm going to be an astronaut when I grow up. That's what I want to do. As I did eventually grew up and I started familiarizing myself with the different aspects of space technology and aerospace engineering, I did get more inclined towards the aerospace engineering part of it over the space sciences part of it. But yeah, I think that was the starting point for me, and I'm incredibly grateful to have had that kind of environment that introduced me to this whole sector. That's how I got interested in space and astronomy.
That's really awesome. And almost all the space lovers have the same case. Like as we we study all the solar system things in our just junior classes. But
Right.
in my case, like my father told me, I think I was in class second or third, and my father told me that we were just talking, and I can remember that he just just told me that humans have gone to moon, and Neil Armstrong was the person to step on the moon, and these were the things, and alien life too. He told me, he just gave me a brief introduction, but it was so much great that I found it great. And then I just saw there were like we always use YouTube videos because it's, we can say, a hub of knowledge. So I started just watching some videos like all, and like I think 1 or 2 years later, I was in class fourth or fifth. A news of Enceladus like came in the news, that
Yeah.
it's it could be habitable for us humans, and it was, I think, that Cassini mission, Huygens Cassini mission. The through this through that mission, through that we can say NASA just found out a new news, found just told us that Enceladus it could be a place where humans can live. Means it's capable of it's capable of habitability and all. So these were the things
Right.
how I got my interest in space and astronomy. But for now, let's get back to the topic.
That was
And
a very interesting story. Like that was so cool.
because that's the thing, because topics in space and astronomy, mainly uh, it's full of mysteries, we can say, dark energy, dark matter,
Right.
yes, time travel, and extraterrestrial life. it has
Yes.
some most like it have some amazing topics with it in it. So now let's get back to our topic of reusable space technology. And first of all, can you just what do you think about this technology? Like, how could it be helpful for us humans and also for space industry? What are the benefits of using this technology, and what could like what more things could be discovered, could be invented in this technology in future?
Right. Okay, so I'll start off by briefing about reusable space technology. So I always like to give this analogy when I'm trying to explain this to somebody. So, imagine you're in an aircraft, right? And you're very close to the airport. The plane is about to land. You are able to see it through your window or something. And all of a sudden, this is a hypothetical situation. All of a sudden, the wings of your aircraft just break up and fall down, and the fuselage of your plane just splits up, opens up, so it's just you in your seat along with your co-passengers. And then as you're approaching the runway, there's a parachute that pops off from the back of your seat, and you are gradually descending onto the runway, and that's how you land. And the rest of the airplane, the wings, the fuselage, everything is gone. If that would have been the case, then none of us common people would ever be able to afford air travel, right? The reason why air travel, especially if you consider the time and distance, like the time it helps you save and the distance that it's actually covering, it is very cheap. And the reason for that is because the plane that you manufacture once is reused so many times to, get that return of investment. But the scenario that I just mentioned is exactly how spaceflight used to work until very, very recently. So you had this Saturn V rocket, which was about 32 stories high, um, which was built with the intention of taking men to the moon. And when those men returned, they returned in a 10 feet high capsule. The rest of the rocket was expendable. Like, that was it. Its job was done. The stages would break apart and fall into the ocean. And it was completely expendable, and there was no intention to reuse it. Which is why, for a very, very long time, spaceflight is considered to be expensive and inaccessible, simply because there was no concept of introducing reusability, and also because achieving reusability in an industry like this is extremely difficult. So what we have been seeing in recent years, as you mentioned, the Falcon 9, which is one of SpaceX's biggest ambitions, is to make sure that they inculcate reusability, because they believe that is one of the only ways that the space race can progress and humans can become a spacefaring civilization. Other than that, Blue Origin also has this reusable technology for their Shepherd flights that they are implementing. So I think this trend has come in very recently, where the rocket that you use to actually carry payload, be it humans or be it cargo, into orbit, that same rocket or that same booster is then allowed to land back down, either upfront. There are other companies like Rocket Lab which are doing some kind of catching mechanism. They're using a helicopter to catch their boosters and so on and so forth. The intention or the final baseline behind all of them is same, is that they want to use that same booster over and over again instead of manufacturing a new one for every single flight. The biggest thing this reusability does is it makes it cheaper. Very simple. The reason why SpaceX in particular has been able to reduce the cost of flight so much is because they've used their boosters 7, 8, 9 times to send it to the ISS, or to send cargo into orbit, or to even send people to the ISS. And this kind of technology and this kind of, path that the space industry is now taking towards reusability is what's increasing ultimately the accessibility to space. And I think if we look at the future, where we have, very ambitious plans of having people on Mars, or even traveling in deep space, reusability is the key to it. You cannot have a system that only works once and then it's done. It cannot be used over and over again. If we are considering that as the final goal, we need to implement reusability, which is very important, not just for the human race, but also for the progression of the space. So yeah, I think that will be my answer to the question of why it is so important.
That's right, because as you said, like the reusable rockets, or we can say technology, space technology, is could be really helpful because it's much cheaper. If we like we can just imagine that if we are making rockets again and again and again, then it's somewhat expensive.
Right.
That's the thing. So like this technology is something that is not easy to achieve. We There must be some story, there must be something that how we like I just want to know that how we achieved this technology, like the about what were the dangers which came in the way, what were the obstacles which came in the way when we were developing this technology. And everything have some advantages and disadvantages. So
Right.
what could be the disadvantages of this technology of using these rockets and all? What do you think about it?
Okay, so I'll start by talking about the difficulties first. So I would encourage all the listeners to go and watch a YouTube video that is, I think, on SpaceX's YouTube channel, and they've called it "How to Not Land a Rocket," and it's just a compilation of all the times that they've failed when they've attempted this landing of their boosters. And I think you will be able to see for how many years this team has been working to try and finally achieve and perfect this whole mechanism. I think a very layman analogy that they often give to explain how difficult it is, especially in terms of control navigation guidance, is that imagine you're standing on top of the Burj Khalifa, which is the tallest tower in the world, and you drop a pencil from the tower, and you on the ground there is a square which is 10 centimeter by 10 centimeter, and you expect that pencil to land from the top of the Burj Khalifa onto that square. That is how difficult, or that is a scaled down version of what they're actually doing with their ship and the booster. Like, that is a very accurate analogy to kind of explain how difficult it actually is. So obviously, it's a combination of all the systems working together, but especially in terms of the control navigation, they make use of grid fins, which are basically aerodynamic structures that help in properly guiding the booster as it is approaching the ship where it's ideally supposed to land. And of course, it is very difficult when you consider so many external variables on top of just the booster engine performing exactly the way that they expect it to perform. You have the atmosphere itself that will be giving you all these different variable outputs on the forces that will be acting on your booster. So all of this combined, it is a very, very, very difficult task. But again, we have companies like SpaceX and Blue Origin who have successfully achieved this. So it is a culmination of years and years of hard work by the entire team to develop this kind of technique, which is very difficult. On top of that, another difficulty, or it might also be called as a disadvantage of reusability, which might be the example of the space shuttle. So the space shuttle wasn't exactly reusable, it was refurnishable. So what would happen is once the space shuttle would land, it would land like an aircraft. And then both of its like side boosters and the shuttle itself would then undergo many inspection tests. There would be some changes to the external structure to kind of refurnish the whole space shuttle again. And then it would fly on the next flight. And the space shuttle was the most expensive thing that NASA has ever done, although it was like with the intention to move towards reusability through refurnishability, but it was very expensive. And we all know about the disasters of the space shuttle through the Columbia disaster, which we all know was when Dr. Kalpana Chawla lost her life. So this can be considered as a disadvantage in terms of you need to be very, very sure of the checks that you do and the checks that you do to make sure the performance of the reusable system is exactly similar to the performance of the original system, because this is space we're talking about. One minor if and but over here can actually result in loss of property, loss of money, and most importantly, loss of life. So I think when we're talking about reusability, we need to be aware and cognizant of the dangers that we might have to face, or the consequences we might have to face if the system, after being reused once, twice, thrice, does not give us that optimum performance. Because ultimately, our first goal should be the protection and the safety. So I think that can kind of be said when we talk about the disadvantages of reusability. Like, we need to be very specific with all the safety checks that we're doing and making sure that all of it is in proper order.
Absolutely. And I just want to know, I think Columbia was the first reusable rocket, right? If I'm not wrong, then.
So the shuttle Shuttle Columbia, it wasn't completely reusable. They used to refurnish it, which basically means that they would make some changes to the external structure, like the tiles, they'd remove it and they'd add new tiles and so on. It wasn't the exact same structure flying again, but yeah, it was a start, like it was a step towards going in the direction of reusability.
Understood. Means, but it also helped us in our work, and it was the first step, as you say. So now let's talk about the Falcon 9, one of the most famous, um, we can say, reusable rocket, and almost everyone knows about it if he or she is interested in space science. And just like Falcon 9 is, I think the yes, Falcon 9 is the most launched rocket ever, and I think it launched, I think, 120 times or so. And it's great because it has, just got success almost every time. And uh, and in some and, uh, it, and it got failure, but only partially, not fully. So it's currently going on, and it's currently still in working. And we all are, really, we all should wish, and we also appreciate the SpaceX work. As you said, SpaceX also faced many failures, but now they are, because with every failure we get to know something new, and
Correct.
then using that something new, we try to improve our technology, we try to improve our work, and that's the same thing with SpaceX did. They didn't left their passion, and they didn't left their interest, and just made it. So
Absolutely right.
just want to know, like, what you think about Falcon 9. What are its specialities and all? Just and yes, also the future of Falcon 9, how it's going to be.
Okay, so I believe personally that the Falcon 9 has been the biggest mascot of SpaceX ever since they began the reusable launches, because Falcon 9 has got them the NASA contract to supply a cargo to the International Space Station. The Falcon 9 was the rocket booster that actually took the first crewed flight, which is a Crew Dragon, to the International Space Station. So after the whole Soyuz thing, for the first time, Americans were launching their astronauts to the ISS from their own American soil by collaboration with SpaceX, the private company. So, and even SpaceX's biggest rocket, like biggest functioning rocket right now, which is the Falcon Heavy, is actually the design itself is just three Falcon 9 strapped together. So I think Falcon 9 has had that impact of being the hero when it comes to SpaceX, their most used product. As you mentioned, that it is the most launched rocket. So yeah, I think it is the mascot when it comes to SpaceX products. And also, I believe that in terms of reusability, what Falcon 9 has done is, again, as you mentioned, that everybody who's interested in space and science knows about the Falcon 9. But I also feel like it has, to a certain extent, brought the space technology to the mainstream, because I believe that a lot of people who don't generally keep up with space news and space technology also know of this phenomena because they've seen videos of this rocket landing, and that is not something like natural. You don't like look at that video and say like, oh, I've seen this before, because no, that is a new technology, and Falcon 9 was one of those key pieces of technology that actually brought this into the mainstream and brought people's attention to the fact that this is what the space industry and the space technology is doing. This is what the engineers and scientists are doing. Because when you look at that video, it looks impossible. The first time that I watched it, I was like, there is no way that they actually were able to do this. It's incredible what they're doing. So yeah, I think for me, my opinion on the Falcon 9, the biggest one is that it's doing the very big thing of making sure that the public is aware of what the space industry is doing. And ultimately, this is very important because for space industry to continue functioning and to continue thriving, it is important to have the interest of the public, because a lot of space organizations are government funded. So if you have the interest of the public at mind, and if you have the support of the public, your funding is going to carry out the way that it is, and so on. So I think that was one of the biggest things that Falcon 9 did for the space industry itself in general. And other than that, technically, like speaking of the technical part of it, I think Falcon 9 was the first one where, like SpaceX's first rocket, where they basically, and I think this is a very interesting trend that you observe with SpaceX. So their first rocket was Falcon 1, right? Which the 1 stands for the number of engines that they were using. So they were using one Merlin engine in the Falcon 1. And gradually what they did was, so with Falcon 9, there are 9 engines at the bottom of the rocket. So 9 Merlin engines, hence Falcon 9. So, and then that pattern is again seen when you talk about the Falcon Heavy, which is medium Earth orbit or a high Earth orbit launch vehicle. But basically, they just pack together three Falcon 9s together. So instead of coming up with a new design for a new launch vehicle, what they do is that they take their existing design, which they're sure that it will work, and then they try to implement that existing design to these new requirements, which is, I think, a very, very interesting way of, one, saving time, and two, saving expenses. And this is a pattern that we've seen at SpaceX for so long. Another thing that you talked about previously with SpaceX was that, with every launch, they are able to recognize their failures and work on it. So they actually work, and I think there are multiple articles online talking about this, is that they work on a technology called as rapid prototyping or rapid scaling, where whatever they feel like might work, whatever the engineers feel like, okay, yeah, this might work, what they do is they try to implement it on a smaller scale and they just test it. And on the test, if they're able to identify the failure, they immediately look at the point of failure and they try to modify their design in such a way that, that failure will not be able to happen in the next run. And with these iterations and with this trial and error, they are able to significantly reduce the time of development. Because if you think about it, SpaceX has been operating for how long? I think 17, 18 years at this point. So within 17, 18 years to go from launching their first rocket to having this fleet of launch vehicles, including the Starship, which they are currently testing, to have this whole fleet of launch vehicles in such a short period of time, I think it has everything to do with the kind of, techniques and mechanisms that they use when they are designing and developing their product. So I think, again, Falcon 9 is a very good example of this technique of taking existing working designs and then moving it to a larger scale.
And yes, Falcon 9 is also not just showing us that nothing is impossible, nothing is impossible, nothing is difficult to achieve. If if we work together and for just one aim, then that aim is going to be successful. And now
Right.
let's get to the last question uh, about the future of you can say humanity, and also in respect of reusable space tech, because future is something that we can't we can't talk about it. We don't know what's going to be happen in future, but yes, it's fun to imagine. It's just awesome to imagine all those things, because we are we can assume that future is going to be great with many technologies fully revolutionized human society and all. Because as we said about SpaceX, we can SpaceX is trying to colonize Mars. Uh, so this is the thing. Uh, Interstellar travel. These are some hypotheses. These are some, you can say, concepts which are still which are still some hypothetical things. But we hope that it's going to be achieved and fulfilled. And in future, I'm sure that these hypothetical things are not going to be hypothesis more. That's going to be reality in future. So just want to know, what are your views about the future of humanity and space, and also in respect of reusable space tech.
Okay, so my opinion, again, this is like what I manifest and what I hope will happen of the space tech, especially like if we start by talking about India. So on Sunday they had this very incredible event where our Prime Minister actually unveiled the headquarters of InSpace here in India. So InSpace is a collaboration between ISRO, the Indian Space Research Organization, and partnership with multiple private companies, startups, and organizations here in India, where ISRO will be providing all types of support, be it in terms of technical expertise or be it in terms of their facilities, which these organizations and companies can use to test their products. So I think starting with that, it is a very big step towards collaboration between government entities and private organizations. And we already know that these collaborations can be incredibly fruitful because, of course, we have the example of NASA working with SpaceX for their crewed flights to the International Space Station. We have NASA working with companies like Lockheed Martin and Blue Origin to develop the lander or the moon lander for their future Artemis missions. And these partnerships are already highly fruitful, as we can see, and it is very nice to see that in India, in our home country also, to have this kind of pattern being followed, where the government organizations are now supporting these private entities, which will really help boost the space sector here in India. So especially if you're in India listening to this, I believe that there's going to be a huge boom in the space industry itself in the next 10 to 15 years. So this is actually a very good time uh, in India and in anywhere in the world if you're planning to get into this industry or work towards work in these kinds of projects. I believe that we are very close to a boom in terms of that. In terms of my expectations for the future of space technology all over the world for humanity, I think we had these very ambitious plans of going to Mars, of going to Neptune, of becoming a spacefaring civilization, of exploring deep space, so on and so forth. Um, I think the rate at which we are going and the missions that we are planning currently, and considering all the players that are currently in the arena, all the private organizations and the government organizations that are working together towards these goals, I think they are not too far away. I think we'll be able to see people on the Mars at least in our lifetime, and I think this is very important for humanity to continue prevailing. We've seen how a virus can literally destroy anything and everything that we know about our surroundings and the world. So now more than ever, I believe it is important to have that big thinking and the idea that yes, we have a backup plan, or yes, we have someplace else to go. So of course, I'm not saying we're there yet, but I think what I'm saying is that we're on the right path in moving towards where we wish to be in the future in terms of space technology. And in terms of reusable space tech, I think reusable space tech is one of the things that is ultimately going to get us there, because in the end, the one thing that it is doing is it's increasing accessibility to people. So you might be hearing of all of these flights of Blue Origin in particular, and even Virgin Galactic, where they are taking space tourists into orbit. One really cool thing that they're doing is they're also using the fundings from these really rich people who are going into space to actually take some really inspirational people up to space. So they took, I think last week or the week before that, they took the first Mexican-born woman who is an engineer at NASA JPL to space on Blue Origin's Shepard. I think they took a teacher a few weeks back on Virgin Galactic's flight. So I think all of these are very important and inspirational to ensure that people, especially people from minorities, people who don't exactly find representation when they look at the space industry, it is very important to have these kind of examples to look up to, because ultimately the generation that is going to make sure that we settle down on Mars or we become deep space travelers, that generation is currently kids or will be kids in a few years, and it's very important to have instances like this that will inspire these people. Like I had role models like Dr. APJ Abdul Kalam and Dr. Kalpana Chawla, and it's very important for us in the future to continue having these role models so that kids get interested in the work that they're doing and get interested towards the space sector. I think that is a very important part if we talk about the future of space sector is to continue encouraging the younger part of the population to explore and learn more and ultimately join this as a career field to help in the development. So I think that is my manifestations and my hopes for the future of SpaceX.
Absolutely. And also, I think you know about it that India's first chemical experiment in space is going to be, just launched by my friend is Nova, and
Yeah,
the founder at
on Skyroot, right? With
yes, on
Skyroot rocket.
Savi. Huh.
Yeah,
Yes. So they are doing a great job, and it's India's first chemical experiment in. It's going to be India's first chemical experiment in space, and we all are really, really excited about it.
that's
This
awesome.
and this all things shows that humans have passion and were always interested and still are always interested in space science. We can also look at our mythologies, which have all those planets at some designations and all in our mythology. So these are some ancient civilizations like Indus and Maya, Mesopotamian, Egyptian. So these are the civilizations, their works, their remains, and all those things shows that humans had passion, had just were interested to know what is out there. So these are the things that clearly shows that humans are not going to be stopped, and they are just going to work. And yes, the young students, like I am also a part of an organization named Nebula Space Organization, and we students, like this is whole like this organization is a student-led organization, research-based one, and for now, like we are creating a satellite and we are creating a rocket and we are working towards it. We are working on some many exciting, we can say, projects and concepts, researching about it. So this clearly shows that the young generation, the students, are really interested in space science. This is not the same thing, especially in India, in we can say 90s or in 2000s too. But like we can say just a decade ago, from a decade ago, all these things have changed, and now now students are just getting their interest in space science and astronomy. Still, in India, there is some scope of engineering is also a part of aerospace and is also a part of astronomy, but still there is a little scope of astronomy in the whole India. But yes, if we compare if we compare the data of decades ago and today, then surely the things have changed. The things uh, with the students, the people are interested, are getting, are working towards astronomy and in India too. And I hope, I I hope that this is going to be, at a this is going to be done at a very great level, and we all are going to be and we all are going to do amazing things in our future.
Yes,
That's
I
what
hope
I
so
hope.
too.
Yes, because these student-led organizations have their correct passion, and they are working at just a very young age, and that's really great. This is an inspiration for all other students who are not working, and no, this is not mandatory, but yes, it clearly shows your passion. It clearly shows how much you are interested, how much you're interested towards the future of space and astronomy, and not only in astronomy but also in medical field and all. Students are working at a really young age. No, students of class 9th, 10th, 11th, 12th. These are the students which are in our organizations, and there are a number of student-led organizations, a number of student-led platforms, and many things. So I'm really excited about all these things, and we are going to do great job.
Yes, I wish you the same, and thank you so much for those kind words.
And it was fun to talk with you. You just elaborated the concept of the topic of reusable space tech very greatly, and I must appreciate that. It was fun.
Thank you.
Really, thank you so much.